Okay, so this is higher question 5, foundation question 6. Food colorings often contain more than one dye mixed together to give the required color. Food scientists use chromatography to separate the dyes in food colorings. The diagram shows a paper chromatogram used to investigate an unknown food coloring, Z, and 3 known dyes. Okay, so just to familiarize ourselves with the diagram, we've got here the solvent front, which is the distance that the solvent traveled. Very often that's water, okay? And then we've got these very stylized chromatograms with perfect dots, which look nothing like the real thing, but this is food coloring Z. It has 3 different dyes or pigments in it. Here's the chromatogram of pure orange, pure green, pure yellow, and then that's for a later question. So how many dyes does Z contain? So if we count the number of dots, we can say that Z contains 3 dyes. Okay, there are 3 dots, so it's 3 dyes. Which of the known dyes are present in Z? Okay, now to get an accurate answer for this, we need to do is take our ruler and ruler a line across level with each of the 3 dyes that are present in Z, and that tells us that 2 of these dyes match with known colours, the yellow and the orange. Okay, so which of the ones are present in Z? It's the yellow dye and the orange dye. Okay, and moving on, the RF value of a substance can be used to identify that substance. The RF value is given by the formula RF is the distance moved by the substance divided by the distance moved by the solvent front. Calculate the RF value for the yellow dye. Okay, so the first thing we need to find is the distance moved by the substance, and in this case the substance is the yellow dye. So if we have a look back at the question, we can see that the yellow dye, and if we just continue that line across to the scale, has moved 3 centimeters. On the solvent front, we can see has moved 7 centimeters. Okay, so that will be 3 centimeters divided by 7 centimeters. And if I just quickly get up the calculator, so 3 divided by 7 is 0.43. We round that number up to 0.43. Okay, so 0.43 is the RF value for the yellow dye. Another unknown food coloring, W, contains orange and green dyes. On the diagram, draw a chromatogram for W. Okay, so back to the chromatogram. So the question tells us that we've got orange and green. So the orange dye is this one here. No, it's not, it's this one here. Okay, so we need to draw a blob above the W that's consistent with that one. And the green dye is this one here. So again, we need to draw a blob above the W, which is level with that one. Okay, so those 2 blobs there define the green and the orange dyes. Okay, so that was question number 5.